Hello, hello, there we go. Thank you. Just to fill the time, so I'm an architect with Mass Design Group. We're a group of architects and engineers. I think we're, as a discipline, as a construction industry, we're at a pivotal point, I think, in human history. It's fair to say, where our discipline has a disproportionate impact on the world and our climate through the built environment. Hopefully we can deal with this technicality here. From the United Nations, this came out last year. Just over a year ago, the IPCC looking at this 10-year window we have to halve our emissions as human beings on this planet to make it livable for our children. Never mind this aspiration for kind of zero 30 years down the road in 2050. And for me, this is an existential question, not for just us as humanity, but specifically us in the construction industry, to be very specific about what it is we're talking about. Half of what? So as a discipline, as an industry, we're responsible for 40% of emissions on this planet. Of that, roughly 30% are related to the operations of the building stock that surround us, that we occupy. And every year, we're adding another 10% of emissions through construction, through the embodied processes of our actions. And I think when you look at these two things and really begin to understand what they are, by and large, as a discipline and the rubric of sustainability has been focused on operational emissions, energy efficient, heating and cooling, how to reduce our utility bills. I would say very little in comparison has been focused on the embodied emissions of the process of construction itself. What's in our materials? Where do they come from? What is the emissions related to it? So this question of half is profound when you think about it. It is the question, I think, of our time. How do we half the current emissions of our existing building stock, which are already sustainable, but I think more importantly, how do we half the embodied emissions of everything we build from today? This requires some complete systematic rethinking about what it means to be an architect, an engineer, a builder, a developer. Every year, based on the projections from the United Nations for future growth, we are building the equivalent of a New York City every month on this planet. And that is all 5 boroughs. That's not Manhattan. That much floor area is being built on the planet monthly. So every year, we're building 12 new New York Cities, and every year that means we're putting 12 New York Cities into the operational part of this pie as well. So it's going to get bigger. And as an architect who's been practicing in Africa mostly over the last 5 years, going forward, the projections are this floor area, disproportionately is going to happen in the developing context, and a lot of it's going to happen in Africa. We started 12 years ago in Rwanda. It stands for a model of architecture that serves society. We're a nonprofit made up of about 130 architects, engineers, filmmakers, from I think we're about 14 different countries at this point. We started with a hospital in Rwanda 12 years ago, the Butaro Hospital, that was done through the partnership with the Ministry of Health and Partners in Health. Out of that, we started this kind of fledgling office in Kigali, Rwanda, and in Boston, Massachusetts, where we started. And we started getting a couple projects on the back of this hospital. And 10 years later, we now have 6 offices across the world and are working. As you can see, a lot of our work has been in kind of developing settings, a lot in Africa, Southeast Asia, but increasingly we're seeing our model of practice take root in North America and the United States specifically. This work is getting kind of recognition, I think, for our approach. There's the Cholera Treatment Center in Haiti on the Times of looking at how architecture could deal with an epidemic like cholera in Haiti and how the architecture was intrinsic to ending the vicious circle. To last year, we had the memorial to Peace and Justice open in Montgomery, Alabama, which was really built around the history of lynching and slavery in the United States. On this topic of measurement, I think I want to spend some time on this slide, which is we believe every project has a mission. That you're not building a library for people to go into, you're building a library to give people access to information, to educate them, to empower them. And the fundamental question of every building needs to be front and center. Why are we building this? The second question is, how are we going to get there as designers, as people? What are the methods that we are going to use through our processes to make sure that happens. And I think impact is where this conversation, I think, can open up a little bit, which is, what are the measurements that we are going to use to track our success? Is this building fundamentally improving the society we're putting into it, yes or no? And through what metrics are we looking at it? I think the question of, are we measuring the right things, would be a good conversation. And finally, systemically, the broader system, how is this project trying to change the system in which it's operating? So that, on top of that general sense of how we approach projects, our principles, kind of recently we've come down to think about what architecture needs to embody, what are the core principles of our profession. The first is good, that everybody deserves design, that beauty is a right. I think that this fundamentally, it doesn't matter where you are in the world, this needs to be a human right, access to beauty. The second is that our projects need to be clean, everything we do, and clean in the most intrinsic way to think about it, that all the materials we use, everything we're putting into a building, we understand where it came from, we understand its supply chain, the hands it passed through, and that it inherently needs to be kind of resilient and regenerative in itself. And finally, fair. I think the labor quotient has really been a part of our success, is our kind of, back to William Morris, is understanding that how labor and the construction process itself is a kind of integral part into the conception of making buildings. So I'm going to use just two lenses to then talk about this question of how do we move towards half in the next 10 years. So the first is the obvious one, the operational emissions. How do we half the emissions of a building? This is Kigali, Rwanda. This is a kind of stand-in for, most, say, African cities in a way, rapidly growing, a lot of foreign investment and construction, some of it fairly dubious, most of it looking like this image on the left. By and large, a kind of model of architecture that's reliant on mechanical systems. And I think this is not just Rwanda, this is writ large the world. There's not a window in this building open since I've been here, for instance. On the right is 40 years ago, the Department of Tropical Architecture at the AA in London had this put up extensive research around design for passive systems for tropical climates, which Kigali is right in there, which is like how you design a building for orientation and ventilation. I noticed this building over here was thinking about it, which is nice to see. This kind of basic back to first principles, we brought to our first project, this hospital, which this is a hospital in rural Rwanda, no electricity when we got there, rolling brownouts from even the generator it had, hard to get fuel there, et cetera, et cetera. How do you design a hospital in a context where electricity is not a given? And so we're back to looking at passive ventilation and the obvious things of how we know these things intrinsically. This is intrinsically good design. Access to views, invert the bed. Every patient has a view of the landscape. Windows open in a hospital, mind-blowing. Cross ventilation, stack effect, all the things that are really core principles of good design that we've largely forgotten in healthcare for any typology necessarily. But on the back end of the success of this, the Ministry of Health of Rwanda said, great, fantastic job in this hospital. We need like 29 more of them. Can you help us? And so we said, okay, let's work on a kind of template, a set of standards that we can then use for all the different hospitals around the country. So we did these typical plans. And the design of this document was really for their procurement department, the people in their infrastructure team, to evaluate designs that were incoming, to look at their own buildings, to kind of build a basic assessment of environmental design, orientation, ventilation, solar exposure, et cetera, looking at how to get the air changes you need in a ward for making sure disease prevention or infectious between patients here, of taking care of just making advantage of ceiling height, floor plate width, and the heat coming off the human body to create a naturally occurring airflow. We've since we've been asked to build 2 hospitals, and this is from this week, which is downtown Kigali, a brand new hospital that's testing this standard and seeing what it actually looks like. So this is the Nyarugenge District Hospital. We were asked to come to a very different climate, Liberia in Monrovia, Rwanda, elevated, perfect climate, 24 to 30 degrees year round. Liberia, hot, humid, very different climate, and to get the kind of same passive, it required a completely different set of passive strategies to get the air changes required. Again, not a lot of electricity available, very costly, what is there? So we did a lot of work with Transolar from Stuttgart around, again, core principles. Where's the wind coming from? What's your diurnal cycle? What's on the site? How's the microclimate affect design, et cetera, to help orient the project. Looking at stack effect, solar chimneys as the principal means to create buoyancy in the building. Again, through either, in some instances when the wind isn't high enough, doing some fan-assisted ventilation, but for the most part, on a good sunny day, this building is breathing itself. It does not need the respiratory, the kind of life support system that is their HVAC. And this is what it looks like. I think that the building systems become the architecture itself, and I think that in themselves, the beauty and the legibility of the project become real. On the other side, I think, is our blind spot as architects. We, until recently, didn't even know what this word meant, frankly. I think that's a broad brush statement, but pretty accurate. For the last few years, we've been tracking our projects to understand what is the embodied energy of our projects, how can we improve, to understand, to get ourselves some benchmarks internally in the absence of benchmarks in the industry at the moment, certainly in Rwanda. So you can see this is a kind of global average for construction across typologies. Currently, and where our average is, it's not quite half, but it's substantially less, which is something we're happy about. 2 years ago, we opened this project, University of Global Health Equity, 9/10, a little bit better. Some decisions were made that, like using concrete masonry units that I was not a fan of, but we did our best to kind of lower it. This year, we just opened a couple of weeks ago, the Rwanda Institute of Conservation Agriculture, where we're at half. And I'm looking at this project, we intended to get down our carbon footprint as much as possible, and very proud to say we think we're there. So this is how we got there. This is the emissions matrix of a project, and everybody, to kind of point to, for the last 30 years, sustainability and LEED has really been focused on this box right here. There's all this other stuff. That's really not been paid attention to. It's from the World UK Green Building Council, came out a couple weeks ago. And all our decisions as architects from an embodied perspective are up front. They're in the product stage and the construction process stage. Hopefully this is falling off a bit here, 1 second. So this is where we need to spend time to really understand our decision making. And out there in the world, there are environmental product declarations, which is to say, this brick is this in carbon footprint, right? The kind of thing that we see in our food quite a bit. That's out there in products. It's not well proliferated in the countries you can see right now. So this system, so kind of one of the bigger European ones, based out of Sweden. All the countries in green have products. Some of them have like 2 products, like South Africa, 2 products. We operate in the gray, right? This is where our projects are. So there's zero information whatsoever to even base this on right now. So that's where we're starting. How do we then begin to develop a knowledge to even have this conversation? We do the dirty work. So here's our geotechnical engineer and our civil engineer on this project, going to quarries, getting material, like testing things, taking them to the lab. The next slide here is all the earth blocks and rammed earth core samples. We took soil from within 10 miles of the site to find the ideal mixes to achieve the strength that we required, right? There's no FFC certified forestry at all in East Africa. So we found a sawmill and we work with them to get certification, to understand what species they have, how they're doing cutting. They don't have a kiln, how do we get them a kiln, et cetera, to kind of build up an industry. As a Canadian, that was second nature to me to use wood. On our kind of bricks and roof tiles, we've been working with a local supplier to do an EPD, and this thing at the bottom, which is illegible, is the entire process of making a brick from quarry to kiln and all of the supply chain along the way. These folks use coffee husk, Rwandan coffee husk as their biofuel, which is really great from an emissions perspective to make their brick. And we've been compiling all this information and basically cribbing our notes as an internal database in absence of any to inform ourselves, okay, for this rammed earth wall, here's its carbon footprint. And this is what this architecture looks like. It's not, it's not foreign. It's a wood-framed structure, earth block, and keeping the cement and steel to the bare minimum. But in the context of Rwanda, this is revolutionary. You would not see wood framing at all. So we're happy about that. Ultimately, this is what the project's looking like. The interiors of the building, you can see earth construction, limit cement and steel, very simple principles to dealing with this issue of half. Go with things like wood. And in this case, you can see we even took the opportunity to push the furniture into this direction. We said, we want the furniture not to be a cheap import from Southeast Asia like everything else we've had to do, like maybe these chairs in the room even. We want to make it here, and let's employ as many people as possible to make it. It's an agricultural project. Let's use natural agricultural materials. On the left, you can see the banana weavers that we found literally at the end of the road that made the couch backs, and on the right, working with a local metal shop to do the kind of broyer-esque frames that they wove them into. Of this project, 96% of all the materials have become within the country, which is a big deal for a developing nation, which has an 18% VAT import, which is great. It keeps it good for it's good for the project budget and it's good for the country. And I think on top of that, 98% of all labor for this project has been sourced within the country, and moreover within 100 miles of the project. So there's the kind of pictures of the various craftsmen we've been working on the furniture. But with our contractor, we've asked for them to give us your hiring data, and this is the district. The project is this green thing in the district, and at the peak of construction, we have 1,200 people on site, and as I'm told, every able body in the district is currently working on site. The question I typically get at this point from your audience, from the audience is, great, you could do this in Rwanda, but it's way too complicated. You could possibly never do it in the UK or Switzerland or any other country here. And this is the question that I'm sure some of you have had in the back of your mind. It's total bullshit. 100 years ago, this is exactly how buildings got built here. And we have migrated so far away from this mode of practice to ultimately be in the position we are now, which was that first slide from the World Economic Forum. So I've reworked the title that was given to me, and I would say that this is a model towards a new model of construction writ large. Thank you.